1.6. In this example, we will see how to work on Smith chart to do the so-called double stop matching design. Again, we use the termination in the previous example, that is ZR equals to 30 minus 40J on a 50 ohm characteristic transmission line. And to solve the double stop matching problem, here are some presumptions. Now, usually for double stop matching, the first stop is connected right at the load, and the second stop will be placed 0.375, that is 3/8 of wavelengths away from the transmission line. And as explained in chapter 7.3, alright, so here's the configuration for the double stop matching. So the prerequisite is, the assumption is the first stop is connected right at the termination. So D1 equals to 0. D1 equals to 0. So even though that you have some solence D1, but in fact, in most cases, D1 equals to 0, and the distance between the first stop and the second stop is D12, which is 0.375 wavelengths. And similar to the single stop matching design, of course, the eventual goal, the ultimate goal, is to have matching, that is to place the input admittance at the center of the Smith chart. So the second stop, the function of the second stop is kind of straightforward. It's the same as the single stop matching technique. For the second stop is to rotate the admittance, which is already in the blue circle. That is, you have the blue circle is the uniconductance circle, the G equals to 1 circle. And once you are at the G equals to 1 circle, at the blue circle, you can simply adjust the susceptance, to move the admittance to the center, the blue one, right? And of course, you notice that there is a red circle over here. So what is the significance of the red circle? It's the objective of your first stop. The first stop, the objective of the first stop is to intersect, have an intersection to place the admittance at the red circle. Why? Because the distance from the red to the blue is 3/8 of a wavelength. Actually, it's 3/4 circle. 这边注意一下你要搞清楚就是这个蓝圈圈跟红圈圈的意义从达到匹配的这个观点来看，从你达到匹配是在最左边嘛所以最左边的时候，在这个 Y 这边的看到的 Y2， 它其实就是应该要是等于1的，在圆心上，对不对？所以蓝圈圈也就是跟我们在做 single stop matching 的时候是一样的意义，也就是说，这一个蓝色的箭头，也就是在虚线的右边一点点的地方，它必须要落在蓝圈圈上。这个时候呢，因为它已经落在蓝圈圈上了，所以我只要跳虚步，我不需要去动实步，我透过这一个 second stop 去调虚步，我就可以把它从蓝圈圈上面的跑外面的位置，把它移到中间过来嘛，对不对？我们刚才已经练习过了，用 show stop 可以做到这件事情。 好，但是这里头 double star matching 的 technique 比较特别一点，它有一个红圈圈哦。这个红圈圈呢，其实就是你的第一个 stop 的目的的目标啊。为什么？因为 double star matching 通常它2个 stop 的间距是固定的，也就是3/8个 lambda。3/8个 lambda 在 Smith chart 上面看起来就是3/4圈。好，所以这红圈圈是怎么来的？它是把蓝圈圈逆时钟转3/4圈，逆时钟方向转3/4圈，有没有看到？好，你会看到这个点、这个点、这个点转3/4圈之后，就会形成这个点、这个点、这个点、这个点、这个点转3/4圈到这里，这一个点转3/4圈到这里。好，所以意思就是说 D12 这一段线路可以让它转3/4圈，所以只要你在第一个 stop 的并联可以让它的导纳的位置落在红圈圈，那么经过 D12 的旋转之后，也就是往顺时针方向转3/4圈，它就会落在蓝圈圈的位置。那么你再用第2个 stop 把落在蓝圈圈位置上面的导纳值移到原点，对不对？好，所以有同学吗？好，当然好了，我认得你的字很丑，来拿过来。还没好，可是我已经不收了哦，你不现在教我就不收了。哦，后来，好 ，OK， 好吧。所以第一个 stop 的目的是什么？把你的那个它所对应的导纳值转到红圈圈上，好不好？啊，因为所以这边的 D1 等于0嘛，啊，也就是说你根据 ZR 值找出对应的 YR 值，然后让它调整虚部，让它走到红圈圈，然后呢，下一步它就会转4/3圈到蓝圈圈，然后蓝圈圈上面呢再把看剩多少虚部要抵消掉，用第2个 stop 把它抵消掉，可以吗？这样有没有了解 double star matching 的？好，接下来我们看一下怎么做哈。So the objective of the first stop is to move the admittance to the red circle, and because the distance between the two stop is 3/4 of a circle, that is 3/8 of a wavelength. So the point on the red circle will be moved to the will be moved to the blue circle, from the red circle to the blue circle. And as you already notified from the remarks, the short stop, can only change the susceptance, but not the admittance. But not the conductance. They can only change the susceptance of the reflection of the admittance. All right. Okay. So first thing to do with the double stop matching is draw the circle. This circle in the textbook is referred to as the auxiliary circle. 所以翻译的话叫做辅助圈吧，辅助圈 auxiliary circle 所以你在做 double star matching 的时候，可能要做的第一件事情是要在下半部也就是正下方。因为红圈圈跟蓝圈圈就是差270度，差3/4圈，所以你要在 Smith chart 的正下方画一个圆所以我假如决定要在期末考 double star matching 的话，我会在 Smith chart 上面先帮你画好，所以你不用担心，好不好 ？Auxiliary circle 我会先帮你画好 ，OK？ 所以第一个 stop 要干嘛？把 admittance 移到红圈圈，然后呢？它转3/4圈就会转到蓝圈圈，但是你要小心的是这一个点会转到蓝圈圈的哪一个地方？这里还是这里？想清楚这一个点会转到蓝圈圈的这个地方还是这个地方？答案是这里答案是这里你要转够270度好不好？你不是转到蓝圈圈最近的那个点，不对你要转够270度所以这个点只要转270度的话，其实是在这边左右 ，OK 转完之后，再根据这个地方的虚部，然后决定你的第二个 stop 要提供多少的虚部来让它能够移动到圆形，好不好Well, you can go over the description for the step-by-step description of the double stop matching technique. So let's work on the real number, right? Okay, so here is the drawing for the oscillatory circle. So you need to know that you draw the oscillatory circle by rotate the G uniconductance circle by 270 degree counterclockwise. So every point move 3/4 of a circle to the new position. And the collection of this new position forms the oscillatory circle. So for example, this point move 270 degree will locate it here, and this point 270 degree will be here. Okay, so here is the formulation of the oscillatory circle. Alright, so let's work on the actual problem. So in this problem, we have a load impedance of 30 minus 40J. So again, the normalized impedance is 0.6 minus 0.8J. What is the normalized admittance? That will be the inverse of this number. That will be 0.6 plus J.8. Okay? So here's the impedance. The admittance is placed diametrically the opposite of point A on the constant SWR circle. Okay, so the first thing is draw the constant SWR circle and enter point A, and then find the opposite of point A and get point B. Okay, so if D1 is not equal to 0, then the point will rotate a little bit. But for in this case, because D1 is 0, so you can simply find the opposite of point A. So here is point A. It's located at 0.6 minus 0.8J. The opposite of point A, which is point B, is located on the constant SWR circle, as shown here, and the value will be 0.6 plus 0.8J. All right? So that is the admittance at the termination, at the load. So you know that in chapter 7.3, we work from left to right for the double stop matching. But in the Smith chart, it's more intuitive. You work from the right to the left. Work from the right to the left. Alright, so from point A, you find the corresponding admittance which is located at point B. Then then you will enter the first stop, first short stop. What is the function of the short stop? Well, the function of the short stop is to adjust the susceptance. 它可以调整虚部。第一个 stop 是调整虚部，调整虚部要达到什么样的目的？让 point B 能够移动到辅助圈上面，对不对？移动到 oscillatory circle 上面。 所以注意哦，这个 short stop 它能够改虚步，它可不可以改实步？不行嘛。所以从 point B 它要改变它的虚步的时候，它是沿着哪一个圈圈在走？沿着实步，也就是 G 等于 0.6 的圈圈在走，因为 B 点的那个实步是 0.6 嘛，对不对？好，那要往上走，往下走，往下走啊，对不对？因为你的辅助圈在下面嘛，对不对？所以你要让 B 点往下走，走到跟辅助圈的交点，有几个交点 ？Again 嘛，两个交点嘛 ，Point C 和 Point C prime，right？ 好 ，so the one option is move from point C to point B to point C. So how much susceptance is needed to move from point B to point C? So to know that, you need to know what is the susceptance of point B. Well, it's point A, all right? According to the dashed line, the susceptance of point B is positive point A, right? And here is the intersection of G equals to 0.6 and the auxiliary circle. So from point C, you can find from the Smith chart the corresponding susceptance of point C, which is minus 0.08. So the total susceptance required to move from point C to point B to C is what? JB1. No, the susceptance provided by the first stop, JB1, is minus J.89. Okay? So this is the susceptance necessary for the first short stop. And how long it is to provide a susceptance of minus 0.89. We can check out the Smith chart, begin from the right, because the short stop starts from the right, and you will move clockwise. And at the beginning, it will provide a negative susceptance greater than 1, right? But eventually, the susceptance, the longer the short stop, the susceptance provided by the short stop reduces as its length increases. So to provide something like minus 0.89, you should move to somewhere around here. Somewhere around here. So it's a little bit longer than 0.125, okay, somewhere around 0.13, I guess. So let's check out the value, okay? So in this slide, you see the JB1 value necessary to move from point B to point C is minus J.89. And the corresponding length for providing J minus J.89 is, as I already shown in the previous slide, you move from this point to, you move from the right of the Smith chart to somewhere down below, and the length is 0.135, okay? My estimation is 0.13, so it's a little bit longer than that. That's the solution for the the first stop. Okay, let's go back to the problem. So by connecting a short stop that provides you with a susceptance of minus 0.89, you move to point C. What next? The next step is follow the transmission line, which has a length of length of a wavelength to have an intersection with uniconductance circle. So it's starting from point C, rotate clockwise by 3/4 of a circle, that is 270 degrees to point D. And as we already mentioned, point D is located on the uniconductance circle. So what is the admittance as point D? Well, G equals to 1. And what is B value? Its B value is minus 0.53. So YD over here equals to 1 minus J.53. So what kind of the shortstop is needed to achieve perfect matching? That is, the shortstop shall provide an susceptance of positive 0.53, right? So what is the length of the second stop? You need to provide a susceptance of positive 0.53. So it's you should look at what? You should look at over there, right? And the length of the second stop will begin from here, going all the way here and up. So it's somewhere between it's about 0.3, right? It should be greater than 0.25, but smaller than 0.5, all right? So if you check up the Smith chart with the B equals to 0.53, the length of the second stop that provides you a susceptance of positive 0.53 will be 0.25, the bottom half, plus a little bit on the third quadrant, that's 0.077. So the length of the shortstop is 0.327. And the first stop is 0.135. Okay, so with the connection of the second stop, you can move from point D to where? To the center. Okay. 所以我们再 review 一遍吧，你进去的地方是 A 点，不过 A 是 Z chart， 所以第一件事情是画出你的 constant SWR circle， 找到它的对应的导纳点，导纳值也就在 B 点那 B 点的值是多少 ？0.6 加 0.8J， 所以第一个 stop 的目的是要让把 B 点移动到跟辅助源交点。那你有两个解，一个是 C， 一个是 C prime。我们先讲 C 好了。所以你只要移动到 C 的话，从 B 点移动到 C， 你要知道从 B 移动到 C， 它的虚部变了多少？10步是 0.6 没有变化因为你接 short stop 也只能够改虚部，不能改10步。那你需要改的10步会是多少？所以起点是 0.8， 终点是负 0.09， 所以它们中间的差值是负 0.89， 所以你需要一个 short stop 给你负 0.89 的 susceptance。所以负 0.89 的 short stop 它会落在哪里？落在下半部嘛，差不多这里嘛。所以我说那个长度大概是 0.13 个lambda 左右好啦，接了这个 short stop 之后，它会移动到 C 点，然后看右边的图，你有一个你的两个 stop 的间距是3/4圈，也就是3/8个波长也就是转270度。注意这个是顺时针转270度，所以 C 点转270度的地方的终点的C 点转270度会落到 D 点嘛，对不对那 D 点呢，因为已经落在 G 等于1的 circle， 也就是 constant conductance circle， 所以它最后的第二个 stop 就是把 D 点的虚部抵消掉。D 点的那个导纳值是1减 0.53J 所以你需要一个正的 0.53J， 正的 0.53 的那个 电纳值来去把第一点移动到中心点，可以吧？那么正的 0.53J 要在哪里？要多长呢？所以大概稍微瞄一下啊，正的 0.53 在上半部嘛，你的 short stop 是起点在右边嘛，对不对？所以要走到第三个象限的地方，你大概要转大于半圈，小于3/4圈嘛，所以你看一下它算出来的值是多少？0.3多吧，0.3几个lambda那接上那个之后呢，你就可以从低点移到中心点了。OK， 这样可以吗？当然，你还有第二个答案嘛，第二个答案的话就是从 B 点移动到 C 点 ，C prime 点。所以我们看这个图啊 ，C prime 点它所对应的虚部多少？-1.8，1.92。所以你的那个从 B 点移动到 C prime 点的那个电纳值是多少？它减了减了-1.92减0.8，所以等于-2.72，有没有？所以你的第一个 stop 要提供的电纳值是-2.72J， 可以吗？这样你才能够从正的 0.8 移动到-1.92。请问正 2.72J 的那个 short stop 是长还是短？我们已经在 Smith chart 上面搞了好几次了，对不对？所以 short stop 假如你要提供负的 2.72J 的话，它是长还是短的？它会落在哪里？它大概落在，你看这边是-1.92嘛，-2.72大概在 somewhere over here， 所以没有很长，对不对？大家可以猜到，这样过来大概不到0.1个lambda吧，好吧 ？Anyway， 所以接了一段短短的 short stop 之后，你可以从 B 点，所以在上面移动的轨迹的长短，不代表你的那个 stop 的长短也不代表你转圈圈的长短有的时候要小心这件事情在轨迹上面移动大不一定对应到的那个真实的微波传输线的线长就是很大不一定这些你移动那么大的范围，但你只要接小小一段而已。好了，接了小小一段之后，把它移动到 C prime 点，然后它会沿哪一个轨迹？它会沿这个轨迹转270度，沿这个轨迹转270度，转到哪里？转到 G 等于1圈圈的上半部 D1 prime 1 prime 这一点，可以吗？270度嘛，沿着那个传输线走270度，走3/4圈到这边的 D prime 点。D prime 点的时序部多少？1加 2.5J， 对不对？1加 2.5J。它本身的那个 G 值的时部就已经是等于1了嘛。所以你的第二个 stop，what is the purpose of the second stop? To cancel out the susceptance of 2.5. So you need a second stop that give you a susceptance of -2.5. So how long is that thing? How long is the second stop? Well, you can guess that because in order to provide a susceptance of -2.5, it should be located somewhere over here. So the length of the second stop is small as well. So you can check up your Smith chart, find out the position that has a susceptance of -2.5, and that will be the length of your second stop. So once we realize the design procedure for the double stop matching, you can check up with the Smith chart to find out the exact number of your design. So here is the solution for the first design. I will check up with that later. And here's the solution for the second design that we move from B to point C prime. Okay, and we know that the first stop should provide a susceptance of -J2.72, and the corresponding stop length will be 0.056. So it's relatively short, less than about 1/10 of a revolution, 大概差不多1/10圈吧，1/10圈，一点点而已。And the second stop, as we already mentioned, should provide us acceptance of negative 2.5. Because this number is, the magnitude of this number is greater than 1, we know that it's not, that the length of the short stop is not very long. So using the chart, we see that 2.5 corresponding to the mark in terms of wavelength is 0.31. And the beginning of the short stop is 0.25, so the length of the second stop is 0.06. So you can see the second solution, even though it's moved a long distance on the Smith chart, the actual design, the short stop length is relatively small, which are smaller than 0.1 wavelengths. Okay, and we can verify the design on the Smith chart. Okay. Yeah, so let's check up with the Smith chart software. Okay, so let me put the number first. So the first design. Here's one last thing we need to discuss about double stop matching. It's referred to as the forbidden region. The name sounds a little bit interesting. Why? Because if you use double stop matching, there are some region, some node, some terminations that you cannot achieve perfect matching using the double stop matching technique. Just as we have discussed in chapter 7.3, we already mentioned that there are some limits about the second double stop matching. That is, at a certain condition, the double stop matching cannot achieve perfect matching. Why? Because this is the equation that we have from chapter 7.3. It tells you that the B2 value, the second stop, the subsequence of the second stop corresponding to this value. And to have a real solution for B2, the things in the square root must be greater than 0. If the number here is smaller than 0, then you have no real solution. So the condition is 1 over G prime must be greater than the square of psi beta D12. So here we have a D12 as for the usual case. For the usual case, D1 equals to 0 and D12 equals to 3/8 of a wavelength. Therefore, the square root the inverse of a square root of beta D12 is 2. Is 2, which means that the real part of Y1 prime must be greater than 2. Why? Okay. Because this number 2 is corresponding to the G prime value. G prime value. Let's see. Okay. So here's a more intuitive illustration about the forbidden region. So as you can imagine, the objective of double stop matching, the purpose of the first stop is to move the admittance to somewhere on the oscillatory circle, right? 我们刚刚讲过了嘛，第一个 stop 的，第二个 stop 目的是要把它转到圆心，第一个 stop 目的要把它转到辅助圆上面。那一旦你落在辅助圆，那因为 T12 已经设定好是3/8个 lambda， 对，3/8个 lambda， 所以它一定会转到G 等于1的那个 uniconductance circle 啊。所以你的第一个 stop 的目的是要把它放到辅助圆跟辅助圆的交点上面去。但你要留意的是，你的 first stop 它只调虚部不调实部，对不对？只调虚部不调实部，所以它在转的时候呢，是沿着那个 G 等于 0.6 啊，还是 G 等于 0.8， 还是 G 等于1的，还是 G 等于 1.2 的圈圈上面去上下转。但你看到辅助圆最右上角，它跟那个 constant G circle 的交点是 G 等于2，对不对？我觉得我们今天看到的红圈圈，所以问题就是说，假如你一开始的负载，一开始的 admittance， 它的那个 G 值比2大的话，比如说 somewhere around here， 所以不管怎么转，往上转或往下转，no matter which direction or how much susceptance you are added to this point。It won't have an intersection with the oscillatory circle, which means you are powerless if the admittance of your load is located within this red circle region, which is referred to as the forbidden region, which means that you cannot find a solution using the double stop matching technique. This result is consistent with the derivation presented in chapter 7.3. Alright? So forbidden region, because we only adjust the susceptance, the imaginary part of the admittance, using the short stop. So once the real power of the admittance, that is the G is greater than 2, then you are powerless. The double stop matching technique is powerless. You cannot achieve matching for real part greater than 2, for G greater than 2 for this case. So that's what double stop matching cannot do. So how about that you do have termination with admittance, the real power of admittance is greater than 2. And you need to use the double stop matching technique. How to do that? Well, you move the circle, you move the forbidden region, you add up, because originally you set D1 equals to 0. So if you increase the length of D1, say for example, if D1 equals to a quarter wavelength, 1/4个波长，那么也就是说你把那个起始点那个 D1 移开来了比如说移1/4个 lambda， 那原本的点呢就会转，原本你的导纳值可能在这边，但是因为你要先走1/4个 lambda， 也就是先走半圈，你就会跑到这边，然后它就有解了但是呢，假如你一开始的那个，假如你那个 D1 等于 0.25 个 lambda， 1/4个波长的话，它其实就是说 double stop matching 的 forbidden region 还在。那你只要改变那个 D1 的长度，你只是把那个 forbidden region 的位置改掉而已比如说我刚刚讲的例子，假如 D1 从0变成1/4波长，那么它的 forbidden region 呢就会从最右边跑到这边所画的最左边。所以还是有 forbidden region 只是说你假如能够去动这个 double stop matching 的那个长度的话，你就可以有机会去避掉那个 forbidden region， 但是 forbidden region 还是在了不是能够完全的避掉，好不好？好了，那好了，时间差不多了，那我们今天就到这边吧。